Hi, welcome to our session on scaling privacy with Apache Spark. My name is Aaron Colcord. I'm the Senior Director of Engineering at Northwestern Mutual. And I'd like to introduce you to Don Bosco, the CTO and co-founder of Privacera. So let's just jump in and take a look at our agenda and what we're going to cover today. So we're first going to cover a little bit of our background, our respective companies, our backgrounds, and why we're coming here together to speak with you today. We're going to talk why privacy, security, and compliance. Why is that important? We'll talk about our respective approaches. We'll begin to place out what is an ideal problem solve for those complex problems, and then we're going to try to put real life into that. Try to bring real life and actually try to bring it all together and tie it together with something that actually we can use. So my background, I work for Northwestern Mutual, and we're actually engaged in building an enterprise scale unified framework for bringing data together in a democratized way. Our company has a very long respected history of about 160 years. So compliance, privacy, and security, they're extremely important to us as almost cornerstones. And we are actually now at the intersection of how do you make agile data actually play along with compliant data?
I am Don Bosco. I am the CTO and co-founder of Privacera. At Privacera, we are doing security and governance in the cloud for the open data ecosystem. We have built our solution on top of Apache Ranger, which provides centralized access management for all the services in the cloud, which includes traditional Databricks workspaces, Databricks SQL Analytics, S3, ADLS, Redshift, Snowflake, and others. We also do automated discovery of sensitive information in the cloud, and we can use this classification for access control and encryption based on classification. I'm also the PMC member and committed in the project Apache Ranger. Anna, back to you.
So suddenly, why do we care so much about privacy now? Well, the way I like to frame it is we have always cared about privacy, and we've always actually relied very deeply on it. But the technology was usually rightly aligned with how privacy worked and wasn't actually moving far ahead. But over a decade ago or 15 years ago, technology suddenly started outpacing our ability to actually catch up with privacy. Suddenly we had mobile phones, we had digital businesses, and the ability for us to actually start capturing all that data as what started outpassing our ability to actually catch up, because privacy is at its core an actual policy and an understanding of like how you're going to actually run your business. So we have always really cared about privacy, but it's really now as we start looking at these technologies of about how to advance and bring data democratization together, where all of a sudden we now have to start looking a little bit deeper at these concerns. And another reason why we also care about privacy is our governments have started really caring about privacy. Up until a couple of years ago, privacy regulations really didn't exist because it was just assumed that privacy was built into your process. So we now have new regulations. GDPR, introduced a couple of years ago by the European Union, has helped us start recognizing how we actually had to implement privacy into our technical systems. And CCPA, implemented by California, also starts bringing us regulation on how to do it. More importantly, if you're in any type of regulated business where you actually have audits or you have some responsibility, you are also care about privacy because it's a risk when you're collecting this type of information about your customer. So a good way to paint this is if you've ever gone to any sort of website now, you usually see like some sort of banner that pops up at the bottom that says accept cookies. That's because browsers now also are looking at how do they protect your privacy? What do they collect? How do they make you aware of it? And so most companies have always published a privacy policy for you to find on their website, but very few people have actually really gone in search of it to really understand how is their data being used. And that's actually a very important aspect of us as consumers, which is actually understanding that when we interact with any type of entity, is how are they going to use our information? Do they plan to monetize it, sell it, trade it, or do they just plan to use it to help actually improve our customer experience and allow the company to actually build their products better based off of the information that they're collecting? So when we round up, privacy is really actually a policy and a legal obligation for any organization to recognize. And the reality is, as our computer systems are getting better, our ability to automate, our ability to understand implementing of anything artificial intelligence, anything machine learning, it's only going to pick up speed. And that's actually going one way, while the other way, more regulations are arriving to actually start regulating more around privacy. So our ability to actually execute our data programs, our ability to learn, and our ability to actually improve our own projects and products is actually highly dependent upon our ability to respect our users' rights. And if anything, just the ability for us to uh, mature our own programs means that we do have to implement the governance program to actually understand what's going on inside our organization. Now, when we talk about another aspect, technology like Apache Spark has really opened up our capability to democratize our data. The amount of ability to process data and to shift through it, look through it, and create new use cases has been greatly enabled by Apache Spark. And another aspect is also that almost every company now is looking at this aspect of how to actually make that their data and their data programs more accessible to their business users. That's through making marketplaces that can enrich and share the data. And then that starts begging the fundamental aspects of privacy. Who in the company can actually view it? Do they actually have the controls to actually protect the information from who's actually looking at it? Can we verify that the information is actually being used for the right purpose? Those are important questions that we actually have to care about in order for us to actually scale it, to actually implement a privacy program. And so we'll emphasize on the rightmost concern, because what is privacy? Because it is fundamentally different than the other two leftmost tiles of security and compliance. Privacy at its fundamental core is actually having the authorized and legitimate usage of that data. And that is fundamentally different than security, because security is actually just protecting the authorized usage of data and keeping those who shouldn't be using the data. But privacy is interesting because we're now talking about a scenario where a business user may actually have the secured right to look at the data, but that doesn't actually ensure that there's actually privacy or the actual usage of the data. And privacy actually goes deeper when it starts talking about the actual owner of the data. What is your consent rights? Did you actually authorize this? Did you actually want the data shared? And this is actually a slippery space, because privacy is ultimately a policy implementation of your organization based off of your how you understand the legal obligations and how you do business, those intersection. It's different because compliance ultimately is actually how you're balancing security and privacy as your main concerns. So let's examine a couple of strategies to scale agile data with privacy. So this is now begin to paint off a little bit about how do we get to our ideal system. Could we actually build our ideal system by building a metadata layer that defines PII in the schema? Well, it's flexible. We can certainly change it extremely fast, but users and developers can and will change where the PII is stored. That means we can actually update it fairly quickly if we discover a new field needs to have privacy or security on it. But there are fundamental problems with that, meaning that we don't really know as if that field is correct. And we can actually basically chase our users around and chase people around to find out, is this actually correct? Or we could also take another approach where we say, look, let's go build some views with the permissions, and we'll just limit those to certain users as we start understanding them. But that's not very scalable. It takes a little bit of work to actually build a view. It takes a little bit of time to actually go deploy it. And then we always have to show who accessed and why. We actually have to understand those information. And really, if you think about it, these scenarios are really security scenarios, not really privacy scenarios, because we still didn't actually talk about, was it the legitimate usage of the data and how did we track it? So let's talk a little bit about those further in those challenges. When we talk about the metadata being flexible, could we actually take another approach and start thinking in terms of policies? We define policies. Is this attribute can we actually look at this attribute and say that this is classified in a certain way and actually represents a certain value? And because of its certain value and what it represents to us, then we should actually secure it based off of who's actually accessing it and understanding that data. That seems a little bit more flexible and a little bit more to what we're trying to do with privacy. We're trying to secure it against the usage of the data. Could we also keep up with our view strategy? Well, the first time we do our project, we'll discover maybe we use 15,000 fields and we inventoried them all proper. But then suddenly we're asked to add one more extra thing, and we discover another 10,000 fields, and then maybe another 5,000, another 2,000. Quickly you're outpaced and your framework isn't scaling and you're falling behind. So thinking in terms of how do you actually implement the same type of access control, but making it dynamic would bring us to an ideal state. And remember, security is fundamentally different than privacy. Security is actually not only a different domain with a different set of skills, it is about whether or not the door is locked or the door is open. And we really are talking about how we're protecting the usage of our customers' data, the people that contributed our data, and then how are we actually making sure that's properly used and leveraged. So with this, I'll pass this off to Don Bosco to talk about how we can actually solve our problems.
Yeah, let's see in real life what happens, right? Our ultimate goal is to ensure that we can protect our customers' personal and sensitive information that we store in our environment. And also we can use them as per the consent that they're given to us. There are a lot of compliance regulations out there to ensure that we follow that. To go through a few use cases, like if GDPR or CCPA is applicable to you, then your customers can ask you not to use their personal data for marketing purposes. Then you are required to expunge those data from your data set, which are used for marketing purposes. In the healthcare industry, a patient might ask you to provide how their personal data has been used. So you're obligated to provide that information to them. And there are other use cases where almost all compliance policies, the constraints on the original source data need to be carried forward to wherever the data has been copied or moved. So if you feel it is difficult, in the real world, it's a lot more complicated. So if you look at this data diagram, the bottom layer represents storage. Data could be stored in object stores like S3 and ADLS in different file formats like Parquet and Arc. And also you have data in databases like Redshift and Snowflake and Synapse. The layer above that is a SQL engine layer. You have tools like Databricks to access data from object stores. And these tools provided structured representation of the data similar to the traditional database. On the left-hand side, you have the different personas. You may have data scientists and architects primarily accessing the raw data at the lower level or the Databricks level. Then on top of it, you have the query virtualization tools like Dremio and Trino, which will provide both data source abstraction and also performance benefits. And you have a different set of users and roles accessing, like data analysts may primarily use Dremio or Trino for doing their analysis. And you have business users. You may use dashboards, or they may use BI tools like Power BI and Tableau, right? Then in an open data ecosystem, data can move from one system to another system, or different tools might access the same underlying data source for different purposes. So regardless of which tool or who is accessing this data, you have to have the same original policies consistently applied across the board. Yeah, to make it more difficult for enterprises, some of the tools used to enforce security and privacy policies could be the same. The privacy team might have their own set of requirements, which will be based on state, country, and other industry regulations. While the security team is responsible for unauthorized access to data leakage and encryption, might end up using a similar tool, or you may build one tool on top of another tool. And then there are data owners who are more concerned how their data has been used and for what purpose, right? And all of them need some level of monitoring, may not be the same reports, but a slightly different type of reports are audit records, right? So now we have to make sure that when we are implementing policies, we're not overriding each other's policies. Otherwise, it'll be very difficult to enforce anything. And also you need to manage them much more holistically. So the best way to solve this problem is to use the right set of tools. First, we need to classify sensitive data and personal data in all systems. Then use this classification to manage access policies, also encrypt PII fields, and also do data cleansing. Finally, centralize the audits from all systems so that we can do checks and balances, generate compliance reports or security reports, do attestations of entitlement. So we'll go through in depth in each one of them. So let's start with data discovery. Right? The first thing, as Aaron mentioned, is pretty impossible in today's scale to do manually classify everything. So you had to automate everything. Right? Then when you're trying to do classification, you should try to be as granular as possible. Example, if you have a Parquet file, it's better to classify at the field level. So instead of saying that a file is containing SSN, if you can identify which field is SSN, then it's easier for you to encrypt or mask that field in the future. Also, instead of just classifying data as confidential or non-confidential, it's better to classify as detailed as possible. If you have phone numbers or SSN or email, then classify them as phone numbers, SSN, and emails. And then you can build a hierarchy on top of it. You can say phone number is confidential, yes or no, or SSN is confidential, yes or no. The reason is policy changes very often. Today, email address might not be considered as a confidential data, but tomorrow it might change and be considered as a confidential data. So you don't want to rescan and reclassify everything. So if you have already scanned and classified an email address, and if you have built a hierarchy, you can just consider that email address is a confidential data. So that way, your policies can be much more efficient. And also, where possible, try to carry forward the source of the data as the data is moving from one place to another place. Example, if you are collecting patient data information from a hospital visit, but due to EPA regulation, you can't use that data for marketing. But the same or similar data may be available from the same user from another channel. Let's assume the consumer has subscribed for a newsletter and might have given their email address to you, and they may be okay to use that data for marketing. So if you have the source data with you, then you can apply different policies for different purposes or usage of the data. Now the main challenge comes is how am I going to tag it and when I'm going to tag it, right? So unfortunately, there's no one place or one way to tag it. So you have to start tagging at the time of ingest, because at that time, you know the source of the data, and you'll be also using tools like Apache Spark, which can help you scan and classify the data. And in the open data ecosystem, data moves from one place to another place. So even though you might have tagged at the source or at the time of entry, the data may move around. So it's very important that you are propagating the tags from wherever the data is going. And this is unfortunately very difficult because with all the tools that we have, it's very difficult to keep track of the tags and where the data is going, right? So one of the ways you can do is you can instrument your transformation job. If you have ETL jobs or you have any jobs going on, you can put additional code in it, or you can use tools like Spline and Spark, which can automatically do it for you. It can capture the lineage, and you can use that lineage to do stitching and propagate the tags. And there's one more thing, right? You may get data into your system through a formal ETL process, but there are also users in your company which may upload their own data. They may get data from open source, they may download from somewhere, and they may upload it into your system. And some of this data might have sensitive information. So you have to keep a watch for that. And you have to, as soon as someone uploads any data, you have to automatically scan them and classify them. And if you feel they're not supposed to bring those data, you should immediately alert it, tag it, and remove it if possible. The next is access control. Traditionally, we have been using resource-based policy. What that really means is you've been setting policies at the tables or the file level. But this is not a scalable model. If you look into today's system, if you have millions and millions of files or objects stored in S3 or AWS, and you may have thousands of tables and columns. So it's very difficult to keep the policies consistent across different systems. So if you're using data classification, once you classify the data, it becomes very easy for you to manage a policy based on tags. So you can say who can see what tags, and you can make sure these policies are enforced consistently across all the different systems. So you don't have to worry about whether it's a table, it's a file. If the data has been tagged, you can allow or deny it. The other thing that you may have to do is try to see if they can use dynamic row level filtering, right? This is a better alternative to views, because views, as much as it has been properly used, but if you have a lot of use cases, it may give to an explosion of views, and it's very difficult to manage. And another downside of views is the user who's running the query needs to know the name of the view. And it's very difficult to keep track of all the different views that are possible and what they support. With dynamic row level filter, one good thing is when the user runs the query on the same table, different set of data are returned based on the user and the purpose of the query. So if you have a data analyst who's running a query for marketing purpose, then the dynamic row level filter can filter out the data for the users who are not even given consent. So in this way, now you don't have to duplicate data. You can provide the same access to the same table to two different users for two different purposes. And in that way, you can keep changing the policy depending upon the privacy constraints. You can apply the same thing for dynamic masking, also for decryption also. With dynamic masking, if the user does not have the permission to see the data, let's say email address, then it will be automatically masked. And the query they will be running will be the same, whether they have permission or do not have permission. Similarly, for decryption, let's assume you're encrypting the data at rest, and there's a certain user who has the permission to see the data in clear text, then you can dynamically decrypt it at runtime. In this way, you don't have to duplicate a data set. And you should also try to plan to integrate your access control with approval workflows. In this way, you can track who's requesting and approving. And you can put additional constraints like term of use, the duration of access, anything else that may be required from the privacy point of view. And it will also help you to come up with better reports. So let's go to the next one. The next one is auditing and reporting. Auditing is also another challenging part. Right? It's so many different systems and logging mechanisms. It's very difficult to keep track of who's accessing data for what purpose. So you should try as much as possible to centralize the audits to one location. And there are a lot of advantages of that. First of all, you can see all the audit logs in one place. Then second is you can generate reports to meet different requirements. Right? Your compliance team may require one set of reports, while your data owners may want to know who's accessing the data and for what purpose. Your security may need audit for some other reason. So having it in one place is much easier for you to consolidate all the accesses, come up with customized report as you need it. And if you're doing classification, then you can also generate more actionable reports, like who is accessing PI data, from which system, and for what purpose. So to wrap it up, for scaling privacy in today's open data ecosystem, you need to implement automated data discovery. You need to have a centralized access control and also a centralized audit culture.
We'd like to thank you very much for attending our session and learning a little bit about how to scale privacy with Apache Spark. If for any feedback and questions, let us know, and we'd love to answer any questions that you have.